In today's video, I would like to introduce you a very nice problem of Bulgarian Mathematical Olympiad edition 1987. Here is the following information. Determine all pairs x and y of natural numbers such that we have this following setup. We have this product: x is multiplied by x plus 1, is multiplied by x plus 7, and is multiplied by x plus 8 equals y square. Okay, so y square, that means the left hand side of this equation is a perfect square. Okay, if you're trying to distribute this product and you try to make a new factorization of the order 4, it will be hard. Okay, so there is a technique to use how to make the connection between these terms, and you get this expression reduced to smallest possible expression in order to solve the equation easily. Okay, I would recommend to give a try to this problem prior getting into the solution. And by the way, don't forget to support us with your like and subscribe. Now let's go ahead, jump into the solution. So I have the following expression. I have x is multiplied by x plus 1 is multiplied by x plus 7 is multiplied by x plus 8 equals y square. Okay, so the idea how to solve this one, I'm going to find out the common term between these four terms. So I'm going to put x as x plus 4 minus 4. Okay, for x plus 1 I'm going to put it as x plus 4. I'm going to keep the same term minus 3 because x plus 4 minus 3 is given as x plus 1. So for the next term I will have x plus 4. This time I'm keeping the same term, but I'm adding number 3 because x plus 7 equals x plus 4 plus 3. For the last term I will have x plus 4 plus number 4 equals y square. I'm going to let's set x plus 4 equals z. Okay, I'm going to put z minus 4 factor z minus 3 factor z plus 3. The last term I will have z plus 4 equals y square. Okay, so it's very clear here. I see z minus 4 and z plus 4, and see also z minus 3 and z plus 3. This one is expressed as a factorization of the difference of two squares. Same thing with this one. So I'm going to group them and make them together. I will put first z minus 3 factor z plus 3. For the next one I will have z minus 4 factor z plus 4 equals y square. I'm going to transfer this one into the original one. I will get z square minus 9. For this one I will get z square minus 16 equals y square. Okay, now I'm going to distribute this product. I will get z square is multiplied by z square is given as z to the 4th. The second term I will get minus 16 is multiplied by z square, minus 9 is multiplied by z square, which is minus 25 z square. For the last term, minus 9 is multiplied by minus 16 is given as 144. Okay, plus 144. By moving y square to the left hand side of this equation, I will get minus y square equals 0. Okay, now it's very clear here. I'm going to transfer this one into the form quadratic binomial equation by doing the substitution here. So we'll get, let's set z square equals c. Okay, now this one equivalent c square minus 25 c plus 144 minus y square equals 0. Okay, now I have ended with this expression as a form quadratic binomial equation. Now it's very simple here. I'm going to calculate discriminant of this one. Let's calculate delta of this one. Delta, I get 25 square minus 4 times is multiplied by 144 minus y square. So we'll get 25 square, which is 625, minus 4 times is multiplied by 144 is given as 576. So that's means 625 minus 576 is given as 49. So 49 plus 4 is multiplied by y square. So here is a problem. We don't know y, what's the value of y to calculate delta. Now we are going to figure out how to make this term as a perfect square. So in order to have a solution for this equation, this term delta must be a perfect square. Okay? Now we are going to work on this one. If you take a look carefully here, the most important observation that I can extract from here. So if you keep plugging the numbers y here in order to get a perfect square, so all the numbers all the way down to the 12 is the only one where the first value starts giving the perfect square, which is 12. Okay, going to check where we have a perfect square. We have this term 4y squared plus 49 is strictly inferior. I'm going to start with this one first. I will have 2y quinary squared. This one is giving us 4y squared. Here is 4y squared plus 49. This term is always strictly inferior than this term, whatever the value of y is. Okay, because we have the same term. This one I have plus 49. Always have plus 49. I'm going to check this term and this term. Then on the right hand side of this inequality, I get 2y plus number 1 quinary square. That's what I'm trying to do now. If I'm going to distribute this one, is giving me 4y squared plus 4y plus number 1. Okay, this inequality is not valid for all the values of y, because if you take in the smaller values of y, for example, if you take in y here equals 1, never verify this one, because here is giving you, because this term and this term are the same, but this term is smaller than this term. If you plug y with number 1, you get 4 plus 1 5. Here is 49. So we need to increase the value of y in order to catch this inequality. Okay, so if you take in 2, that doesn't work, 3 doesn't work, 4 doesn't work, and all the way down to the 12. If you plug number 12 here, you get the same. And this one equal to this one. If y equals 12, to have this one is strictly inferior than this one, y must be strictly superior than 12. Okay, that's mean this inequality holds if y strictly superior than 12. So what does mean? That's mean this one is not a perfect square for all y strictly superior than, because this term as a delta is located between two consecutive squares. Okay, since we don't have the perfect square above this point, y strictly superior than 12, that's mean we have a perfect square when we have y is inferior or equal to 12. In the other word, we have a solution for this equation if we have y is inferior or equal to 12. This one is telling us y is inferior or equal to 12. Now we will have a perfect square. So y is taking following values. It's taking 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay? If you check in all this value to see you have a perfect square or not, just simply take these values of y and insert it here into delta. Is giving you, if it's giving you perfect square, that's mean we have a solution for this equation. If it doesn't give the perfect square, that's mean is not a solution. Okay, so if you check number one is not gonna work here, because 49 plus 4, which is 53, is not a perfect square. This one will be ruled out of this possibility. Same thing with number 2, rule out. Same thing with number 3, 4, 5, 6, 7, 8, 9, and all the way down, except number 12. If you plug number 12 here, is giving you delta equals 625, which is 25 square. Okay, so the only solution that we have, that's mean delta equals 49 plus 4 is multiplied by 12 square, which is 625, which equals 25 square. Okay, by solving this equation, I will have C as a solution equals 25 plus square of delta, which is 25, is divided by 2. So the second solution, so we don't have the second solution, because we have 25 minus 25, which is 0. So y equals 12, that's mean y square, which is 144. 144 minus 144, which is 0. So I'm going to take C as a common multiplier. I will get C factor C minus 25 equals 0. C, I have two solutions, C equals 0 or C equals 25. C equals 0 doesn't work because we have natural numbers. Natural number is a whole number, start from 1 and up. So C is not a, C equals 0 is not a solution, okay? Because C equals 0, that means Z square equals 0, that means Z equals 0. That means Z equals 0 here. That means X equals minus 4, which is not correct because we have a natural numbers, okay? So now I'm going to find the unique solution for this one, which is C. I will have 25 plus 25 is 50. 50 is divided by 2 is giving us 25. Now this implies I'm going to insert this value of 25 into Z square. I will get Z square equals 25. I will have two solutions. I will have Z equals minus 5 or Z equals 5. Z equals minus 5, it doesn't work because I will have minus 5 here. By moving over 4 to the right, I will get minus 9, which is not solution because we have natural numbers. So that's mean Z equals minus 5 is going to roll out of this possibility. That means Z equals minus 5 is not a solution. So I'm going to keep only this value, Z equals 5. Then I'm going to take this value of Z and plug it into the original setup to find X. So I'm going to do it here. So we'll have X equals Z minus 4. By moving 4 to the right, I will get Z as a 5. Z equals 5 minus 4 is giving us 1. So X equals 1 is a solution. So now I have pair of the solution, X equals 1. This one is giving us this solution because Y it was 12. Because Y equals 12. That's why it's giving us X equals 1, because Y equals 12 is a solution. That's mean X equals 1. I will have Y equals 12 as a solution. We found only one pair solution of this one. So I have done this problem. If you are anxious to watch this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you in next video. Bye.